and so on, right? Now we just have multiple independent variables, or x's. This is kind of what we were just talking about today, right, with your group. You still have that single dependent variable, but now you have other factors that influence it, right? By now, you guys should know this because we've been talking about that general format here. All right? The steps that we are going to do follow the same exact 5 steps that we did when we talked about a single independent variable. Okay? What are the correlations? Are they significant? Right? We would do our individual correlations the same exact way. Okay? So we would have our correlations, okay? And I showed you the easier way to do it, where you just highlight all the data, go to data analysis. I'm going to be using chapter 15 Excel. It should be on the portal. The first tab should be Camry.
You wouldn't highlight the car, right?
You wouldn't highlight the car. That's just an indicator. Okay? But let's do that together, and then even though I did it a little bit earlier, so we can all see it together. So when we did our correlation, so step 1 again is analyze correlations. All right, this is under data analysis, cleverly hidden under correlation. Highlight everything, including when you use data analysis, always include the headers. Labels in first row, pick out where you want it, I'll put it right here. And we have what's called the correlation matrix. Okay. Now you can look at the diagonal line, it's all ones. Why is that? And this helps you understand what we're looking at. The first one you see is the correlation between price and price, of course. Then mileage and mileage, of course that's going to be 1. Age and age, of course that's going to be 1. Right? Because they are the same variable. But everything else is every single combination of pairwise correlation. You would get the same result if you did equals to coral, highlight one, then the other. But then you would have to do it how many times? You'd have to do it 3 times here. But if you have another one, then you would have 7 times that you would have to do it, right? So this is a helpful way to do it, to look at your correlations. Okay. Now, in order to test the significance, that you have to do again by hand. But you would have to do it the same way. Is the correlation between mileage and price significant? You would have to go back and do the same equation we did from chapter 14. I don't have a lot of time today, but remember that equation that was the... My marker speed's terrible. This r over the square root 1 minus r squared over n minus 2. Right? You would do that the same way that we analyze the correlations. Okay? I'm going to come back to this in a little bit, but any questions about that and how you can do it? Because as I was mentioning before, it is important to have all the pairwise correlations. Alright, very good. Our next step is again to determine our regression equation. Same steps we did in chapter 14. Alright? How do we do this? We again just go back and let Excel do the work. But I want to show a little bit different interpretations of some of our values here. So we go to data analysis, and our regression. We're only going to have one y variable. There's only still one y, and that's our dependent variable. We're trying to describe the price of the car. So in the first box here, we're just going to highlight our dependent variable, which is our price. If I went too fast, let me know, but kind of a repeat of what we did before thus far. But with our independent variables, now we can simply just highlight all of them. Whether you have 2 independent, or 3 independent, or 4 independent, you can highlight them all. Alright? So, in this case we only have 2, mileage versus age. So notice I highlighted both columns together. I started at C1, which is the mileage, and I ended at D21, which is this 20th observation. Alright. Labels, first row, confidence 95%, output range, I'm going to put it right here, right underneath my regression equation. Okay. So let's take a look and analyze all this. Notice the only difference is now we have mileage and age. Okay? So let me make sure everyone has that. You should have. No. Remember your y is only one variable. That should be just your b. Okay. Yep, just that. And then that should be C and D. Yep, exactly. And then click where you want it. I7, okay, that's good. Okay. There you should have it.
I just saw total in 20.
Okay, you have everything looks good. Alright, so working on. How you guys doing over here? We're good? There you guys are all good? Alright. Now what is our regression equation? If I turn back to this, right, so again we want our second step is regression equation. What is our intercept? Looking at this, where do we see our intercept? What is this B0 value? Say it out. 28,253, correct? So our y is equal to 28,253. Maybe purple would be better. Okay. Right here, correct? It would be minus 0.142 times what? What's our x1 in this case? Mileage, right? Minus 986.7 times years. Okay? Now, these are the marginal impact. These are the marginal values. If we increase mileage by 1, if I drive my car 1 mile, what happens on average to the value of my car? It drops by. Nope, mileage. If I drive 1 mile, the value of my car goes down by 14 cents. Exactly right. That's the marginal impact. 14 cents, that may seem stupid, but if I drive to Pennsylvania, I am driving 1,400 miles, right? If I drive 1,400 miles, what happens to the value of my car? Right? If I drive 1,400 miles, the value of my car goes down by $200. Right? Because that's the marginal. If I increase mileage by 1,400, times that by the marginal impact of each mile, you guys follow me? The value of my car is going to go down by $200. So if I want to see my parents, is my car value, not only do I have to pay for gas and all this, but the value of my car is going to go down by $200. Right? Do you guys see how that marginal impact is? It's very small, but it adds up. I drive 5,000 miles per year, or 10,000 miles per year. You can just plug in those numbers.
Can you click on there again so I can see, because I thought I put it in a different number.
This, where I got this 199?
Yeah.
So all I did is, if I drive 1,400 miles, 1,400 miles times, what is the marginal impact of each mile? That negative 14? That's just how I got it. Right? I just put it in there. Okay? Likewise, if 1 year goes by, right? If Brian becomes a year older, his car does too. What happens to the value of his car? Increase year by 1, the value of your car goes down by $986. Even if you don't put any miles, right? because this is holding all else equal. If everything else stays the same, and that's a new term that we have here, this all else equal term. We didn't have that before because we only had one variable. But now we have to say, holding all other independent variables constant, changing this one by one, this one independent variable by one, will change y on average by whatever this number is. Okay? Kind of cool. Alright? Now, we're going to combine things a little bit, but now that we're focusing on these independent variables, we see they're of expected sign. Now, are these individual variables significant or not? Where do we turn? Do we have to do any more work? No, we just have to look at this. Are these individual coefficients significant? Is mileage significant? Fleur White, what are you looking at? What column?
Well, your p-value.
Yes, yes.
So it's really, really small. That means that you're
Yes.
99%.
Exactly, right? You look at the p-value. The p-value right here, this is going to give us the significance, I like this purple, of individual coefficients. Okay? If the smaller this p-value is, as we've done in hypothesis testing and this, the smaller this value is, the more significant that parameter is. In this case, my p-value is 0.002. Maybe to put this in better words, maybe when you write your paper, it might be better to say, I'm just going to put equals 1 minus that value. So how confident am I? I am 1 minus this is 0.997. I am 99.7% confident that this coefficient is significant. Right? Now, let me write this up here just so we know exactly what we're testing here. What is our null when we look at individual coefficients? What is our null?
But it does not change.
Perfect.
Gross.
Perfect, perfect, perfect. When we look at this, the null hypothesis is that, look how I'm writing this, beta I. What is I? What is I? I could just be whatever indicator you're talking about. In this case, we're looking at mileage. The next time we're looking at age. The next time we're looking at education. The next time we're looking at this. The null hypothesis is that that coefficient is insignificantly different than 0. Okay? We are trying to prove that that coefficient is not 0. We are trying to prove that that's not 0, that it's significantly different than 0. If it is insignificantly different than 0, that variable has no significant impact on our dependent variable. Now, I reject the null with 99.74% confidence and state that the mileage of the car significantly affects the value of the car. Right. Same test, but for the years. 0.03. Yeah, go ahead.
So does it just have to be that it's 95 or above? Is that when
We want this to be less than 0.05.
Okay.
If this is less than 0.05, we are over 95% confidence.
Right.
Now, a lot of times, when I republish papers, when I publish papers with econometrics involved, the way that we write it is we tend to we'll put 3 stars next to a value if we're at least 99% confident, 2 stars next to it if we're at least 95% confident, and 1 star if we're at least 90% confident. So we can say that as long as we're 90% confident, it gets a star, right? But we always distinguish between in this case, this would get how many stars? 3 stars, because I'm more than 99%. How many stars would this get? With that kind of just thinking about it, it would get 2 stars. Because I'm over 95% confident, but I'm not quite 99%, I'm 97% confident. If this was 0.08, it would get 1 star. I'm 92% confident if it's 0.08. I'm more than 90%, but, so you kind of take 1 minus that to get how confident you are. In your papers, if you have anything that is over 90% confident, you can write it's significant, right? That's fine with me. Right? Now, another way to express it, and you guys are going to love me for this, this is the only confidence interval we do for chapter 15. No more confidence intervals for y hats. You have to do it for chapter 14, but not 15. Okay? You can do it, but we have to use a different version. We have to do the pH tag. So with this being said, we get the same result with the confidence interval. What these interpretations are, let's stick with mileage, right? We know on average, if we increase miles by 1, it goes down by 0.14 on average, right? But I can say with 95% confidence that if we increase the mileage by 1, the value of the car will go down between negative 0.5 cents and negative 22.7 cents. Yep, absolutely. All right. We know on average, if we increase mileage by 1, the value of the car goes down by 14 cents. That's on average. What the confidence interval is saying, if we increase mileage by 1, I am 95% confident that the value of the car will go down between 5.7 cents and 22.7 cents. Right. On average, 14 cents. But my confidence, my 95% confidence interval is between 5 cents and 22 cents. Or 5.7 cents and 22.7 cents. Right? So that's why I put it up here. On average, it will go down by this, but I'm 95% confident, that's the definition of confidence interval, it'll go down in between these 2 values. Does that help out? Alright. So notice there's not a whole heck of a lot difference between what we just did and what we were doing before, and how we write out our regression equation and how we analyze our individual coefficients. Now, the last part I want to mention here is this business of y hat. Okay. Now, when I say y hat, our predicted value for a given x, that's what we did before. What I will have to give you, are you guys good with this, or can I erase this real quick? Me and this author have a lot in common. He likes golf, there's a lot of golf examples, and he drives a Camry, I drive a Camry. Alright, my Camry, in real life, has about 57,000 miles on. So this is my mileage of Josh Hall's Camry. I bought my Camry brand new in 2012, that means my Camry is 5.4 years old. Just paid it off 4 months, or about a couple months ago, right? So if you're looking at my Camry, which I can't point to because now I need to ride my bike to work, right? What is the value of my Camry? Predicted value of my Camry. If this is the information you have all this information about other Camrys, I give you this, what is the predicted value of my Camry? What is the value of Dr. Hall's Camry? How would I get this? Now, on your homework and everything else, these are the X's that I give you for a specific car. What is the value of Dr. Hall's Camry? This would be equal to, let me get something real quick here. Take off italicized. It is equal to, well, a regression equation. 28,253 minus mileage, this is always going to be plus because the negative's there, plus mileage times, well, how much miles does my Camry have, plus age times how old is my car, 5.4. Right? Notice I just used my regression equation here and just plugged in my mileage and my year. So if you guys, if I want to sell my car and get a new one, you have this information and I press enter. The value of my car is $14,817. That's the projected value of my Camry.
Can you do that one more time?
Yeah, I can't get that.
Okay. Equals, just plugging in our regression equation, equals intercept. Intercept is 28,253. So I just clicked on that box. Plus, plus, just think about it up here, it's always plus, because the negative's already incorporated. So it's always plus the coefficient on mileage times the mileage that I gave you, 57,000 miles, right? Plus the age. The coefficient on age times what? The actual age. Now, if you have 4 independent variables, I would have to give you 4 supposed. Suppose the graduation rate is 96%, that the average income is 35,000, that the unemployment rate is 5.6%. Then you can predict the incarceration rate. Right? The more you show me in your paper, the better grade you're going to get. So this is the predicted value of my car. That is 57,000 miles and is 4.5 or 5.4 years old.
Yeah, it's not coming up to that.
I don't know, I'm not getting it. I
14,000.
have like negative 58,000.
Oh, my car is worth more than that. Let me see what you're doing. All right. So where are you putting this in?
Here, and
Okay. So
so.
let me look at it. So J13 or J23 plus J24 times B30. No, B30. Okay. Plus J25 times B31.
These are the miles plus the miles.
How about parentheses on it?
Anyone else not getting it?
I'm not getting into that.
I got it.
Did I know what I have?
You said, California.
Okay, so